f double prime of x is minus 60x minus 20. Then they're giving us some information, and they want us to go all the way back to regular f. So do you understand the question? We're going to go from f double prime to f single prime to regular f. Each of those is an anti-derivative step because we're taking off a prime, taking off a derivative. So here we go. So antiderivative will go to a single prime. Okay, what's the antiderivative rule? You have x to the n, antiderivative. You add 1 to the power, the opposite of the derivative, and divide by that. So this is a 1 power. And put the 6 minus 60 here. I'm going to add 1 to the power, x squared, and divide by that. Now, what am I going to do with the minus 20? Well, just think it backwards. It's minus 20x. See what I mean? This is anti. What do I mean? I mean, if I took the derivative of this, what would it be? It'd be minus 20. It would go back. So this must be the anti. Plus constant 1. We're going to have two constants on this one because we have two steps backwards. So constant 1. Now, how do we find that? Well, they tell us f prime of 1 is negative 57. So when I plug in a 1, what's this going to be? Minus 30 times 1 minus 20 times 1 plus constant 1. They're telling me it equals minus 57. It's equal to minus 57. So I can use that to solve for constant 1. This will be minus 30 minus 20 plus constant 1 is minus 57. And so now that is minus 50 plus constant 1 is minus 57. Add 50 to both sides. Boom, boom. Constant 1 is minus 7. So we got constant 1. So let's rewrite our f prime function right here. So this is minus, because now we know constant 1. We're going to rewrite it now with the knowledge of what constant 1 is. Minus 20x, right? Plus constant 1, which means minus 7. So there it is right there. So we just took f prime, single prime, rewrote it now with the knowledge of constant 1. Okay, so we've done one anti-step. We're from f double prime to f single prime and solve for the constant piece. We always have a constant whenever we do an antiderivative because because it's like there's a zero out there. And the anti of zero is any constant. That could be any number, 7, 8, 9, whatever, because the derivative of it would go back to 0. So it's like it's not even there. All right, now we need one more step because they want us to get all the way to regular f. So we have one more antiderivative step. We got to take off the last prime. What do we get? Bring down the minus 30. We do anti here. Add 1 to the power, x to the third, and then divide by 3. This guy, add 1 to the power, bring the minus 20 here, add 1 to the power, x squared, divide by the 2. It's the anti. What about the minus 7? What's the anti for minus 7? It's minus 7x, right? Because the derivative of minus 7x would go right back to minus 7. So this must be the anti plus constant 2. We have a second constant. We got to find that. So we use the other piece of information they gave us, which is right here. F of 1, plain F, no prime. F of 1 is negative 28. So F of 1, so that'd be negative 10 times 1 cubed minus 10 times 1 squared minus 7 times 1 plus constant 2 is, was it 28? F of 1 is 28? Oh, negative 20. F of 1 is negative 28. So is negative, let me change that as negative 28. So we can use that to solve for constant 2. And so what do we got? minus 10, minus 10, minus 7, plus constant 2 is minus 28. Minus 10, minus 10, minus, that has to be minus 27. Plus constant 2 is minus 28. Add 27 to both sides. Boom, boom. Constant 2 is minus 1. We found constant 2, and we have our function. So our function f of x, I'm come back here, is this piece. That'd be minus 10x cubed minus 10x squared minus 7x plus constant 2, which means minus 1. There we go. Let's see if it's right. It's right. There we go. So what did we do? We did two antiderivative steps. From f double prime to f single prime and found constant 1 by plugging in the information. And then from f single prime to regular f and plugged in the information to find constant 2. And so there's our regular f function, two antiderivative steps. And there we go.